Welcome to Pipe Math. Today I will introduce you to our pipeline highway crossing module, which is based on API 1102 code. During the first part of this video, I will show you how Pipe Math works, and the second part of this video will show a comparison between the results of Pipe Math and also the example presented in Annex B of API 1102. So right now we are just entering the project information, which will show on the PDF report at the end. So this, we also have a option to import the signature here, and they will also show on the PDF report. So we are done with the project information. This is a 12-inch pipeline and liquid pipeline, so ASME B31.4, and nominal wall thickness is 1/4 inch, X42 grade. So allowable stress factor for effective stresses is 0.72, 1000 psi is design pressure. We have selected the appropriate soil parameters, electric welded pipe, and 6 feet burial depth for this crossing. Pavement is flexible and bore is the construction method. So we'll run the calculations, and Pipe Math will calculate. So you can see here the stiffness factor is calculated, burial factor, excavation factor is calculated, and circumferential stresses by earth load are calculated as well. Stresses due to the live load, again design load for single and tandem, and axial configuration is tandem loading is the governing case for us. And then surface pressure is 69.44 psi. Impact factor is 1.47. So highway cyclic stresses, and so cyclic stress is due to highway vehicular load is 1444. So let us move on to the cyclic longitudinal stresses due to highway vehicular load, and you can see geometric factor, pavement type factor, and also highway axial configuration factor, impact factor, and surface pressure. All values are calculated, and the results is 1017 psi cyclic longitudinal stress due to highway vehicular load. So stress due to internal load, which is the internal pressure of the pipeline, 1000 psi, and Pipe Math has calculated 25,000 psi stress due to internal load. So now we are checking for the allowable stresses. So allowable stresses has been calculated as 30,240 psi, which is essentially a multiplication of SMYS or a grade multiplied by the design factor. So 25,000 is definitely a lot less than 30,240. So it is showing okay at the end, no concern. So now calculate the principal stresses, circumferential stresses, longitudinal stresses, and radial stresses are calculated. And based on those three principal stresses, the total effective stresses are also calculated. So finally, we are moving to our check for fatigue. Fatigue endurance limit of girth weld and fatigue endurance limit of longitudinal weld has been determined by using the code, and now we are comparing these values by cyclic circumferential stress and cyclic longitudinal stress due to vehicular load. We are done with the calculations, and we will be moving to generate the PDF now. You can see the PDF has been generated, and you can see the first page is showing all the inputs, design inputs for the, from the project, and the second and third page of the PDF report is presenting results. So let us move to the next part of our video where we'll be comparing results. So we will be comparing results in this part of the video. So results will be presented from PipeMath and also from the example presented in API 1102 Annex B. So, this is the first slide. It is comparing the values for circumferential stress due to earth load. And you can see stiffness factor, burial factor, and excavation factor. The values are fairly comparable or almost the same. And finally, the circumferential stress is also calculated by PipeMath is 3123 psi, which is fairly close to the number presented in API. So next slide, this is cyclic circumferential stress, and it is again, we are comparing our values in second column and third column. So you can see the numbers are same, and we are, the final row is presenting the cyclic circumferential stress, which is 1444. Cyclic longitudinal stress, same way, you can see the column second and column third, which are comparing the values, and numbers are comparable or same. Okay, so on this slide, stress due to internal load, which is the pressure. So PipeMath has calculated 25,000 psi. Example is also has given 25,000 psi. So exact same numbers. So on this slide, we are checking for the allowable stresses, and PipeMath has calculated 30,240 psi, which is the same provided in the example. So this is on this slide we are comparing the principal stresses and the total effective stresses. Again, you can see the circumferential, longitudinal, and radial stresses are fairly almost the same, or in the same ballpark. And finally, the effective stress is 26,900. This is the last slide where we are comparing the checks for fatigue and cyclic longitudinal stress and cyclic circumferential stress. And again, you can see the example in second column and PipeMath results in third column. So they are fairly comparable or same. So that is the end of our presentation, and I hope that you have liked this video. Please stay tuned with our upcoming videos to explain our other modules. And if you have any feedbacks, we will appreciate if you can write us on support@pipemath.com. And keep up the good work and have a good day. Thank you very much for watching this.